There are thousands of satellites which are circling, artificial satellites which are circling the Earth, and more than 50 of them, roughly let us say 50 to 60, they are all working satellites of India. Okay, as I told you, there are satellites which are circling the Earth. As I told you, some of them are coming now. That's why I'm repeating. Artificial Earth satellites of India, they are playing a very important role in telecommunications domain, television broadcasting, high-speed internet, weather forecasting, survey and management of natural resources, monitoring of the Earth system, and navigation, of course. But so these are the roughly about 50 satellites. I have shown only two orbits, polar orbit and geostationary orbit. But there are other orbits in which they are there. But there is one satellite, to be more precise, but there is one spacecraft which is not orbiting the Earth, but today it is orbiting the Sun. It is orbiting the Sun. It has not gone to the Sun. It is orbiting the Sun, and it is at a distance of about 15 lakh kilometers from the Earth. Look at that. That is the thing. So if you look at this is the Sun, this is the Earth, and this is the spacecraft. Let us see, this is the spacecraft, and this distance is 15 lakh kilometers, but this distance is 15 crore kilometers. So it's quite safe, you need not have to worry. It is from a distance, when it is at a distance of 15 lakh kilometers towards the Sun, okay, in a straight line, then it is able to observe the Sun 24 hours a day. Why do you want to observe the Sun 24 hours a day? I'll come to that. Okay, this is a very important spacecraft. And you know, to study the Sun in a comprehensive way, it has got 7 scientific instruments. Scientists actually, they call these scientific instruments payloads. Don't worry about such names. Scientific instruments. Let us say Aditya L1 to study the sun 24 hours a day. It has got 3 types of eyes. One eye is capable of seeing the visible light and to a certain extent infrared, visible light. Another eye is capable of seeing ultraviolet light. The third eye is capable of seeing 2 types of X-rays, third and fourth, let us say. X-rays, third and fourth eyes, okay. Then, in addition to that, Aditya can taste the surroundings. I am using the word taste. That means it can directly measure something. What is that? Atomic particles, ions, as well as the magnetic fields. So these things, totally 7 instruments. I'll come to that, all these. Look at the sun. Now, Aditya is capable, idan bekara off madbudi, this light. Aditya is capable of observing the sun 24 hours a day. First of all, why should we study the sun? Okay, intellectual curiosity is different. We can study the sun and understand it and all those things. That is different. But are there any practical reasons for as to why we are studying the sun 24 hours a day? That too today? Yes, there is a reason. I'll come to that. Now, sun is the nearest star to us. It is roughly at the center of the solar system, let us say, and this is the nearest star. Now, compared to the sun is at a distance of, you can ask me later. You kindly reserve your questions. Sun on the average is at a distance of 15 crore kilometers from the sun, from the earth, I say. You know what? Leave the sun. The next nearest star to us, how far away it is? If you consider sun is at a distance of 1 kilometer from the earth, just for the sake of understanding, the next star is at a distance of 2,70,000 kilometers. So, if you want to understand a star, better study the sun. It's very near to us. That's what is being done. But why 24 hours a day? I'll come to that. Now look at the sun. Yeah, what a beautiful sunrise. You may ask, so why? What is the reason? Why we want to study the sun? It is there after all. Every morning it rises, every evening it sets. It won't go anywhere. What is so special about it? We see the moon also like that. I'll come to you later. You can ask me questions. Kindly reserve it. Then, let me tell you one thing. Sun is the life-giving star to the earth. Otherwise, if sun were not to be there, earth will be a cold, dead planet. Once the sun gets extinguished, I'm using the word cautiously, don't get scared. It will not be in your grandchildren's time or great-grandchildren's time also. Wait for at least 300 to 400 crore years, then only sun will get extinguished. But anyway, as of now, sun is the life-giving star, and otherwise we are bust. Sun is responsible for the weather, unequal heating, okay, of the earth gives rise to weather, climate. Climate is at the average, global level. In fact, I am telling, ocean currents. All these things are due to the sun, sunlight, and melting snow, formation of the snow, as well as everything is due to sun only. Without sun, there is no life on earth for all practical purposes. And what about the fossil fuels? Natural gas, petroleum, coal. In what way they are related to the sun? Yes, they were all formed about, let us say, 20 crore years back, roughly. Coal. I know a lot of trees were there. Once they were dead, they were buried. Due to the pressure from above, heat from below, they got transformed to coal. And now within 100 years, 200 years, we are taking out everything. Okay? Millions of years it took. Tens of millions of years. Then there were very small bodies in the oceans, okay, in the seas and oceans, and those microorganism kind of things, they were the ones actually which were dead after some time, and they also were buried, and a similar process was responsible for the formation of natural gas as well as petroleum. And what about photosynthesis? See, one unique thing about life is, the thing is many life forms, okay, at least a group of them or a part of them, they prepare their own food, okay, through photosynthesis. For photosynthesis, sunlight is essential, otherwise photosynthesis cannot. That all equation, high school equation, 6CO2 plus 6H2O is equal to C6H12O6, and oxygen release. Let's not worry about all those things without the sun. First, plants, they generate food, okay. Then herbivores eat that, carnivores will eat the herbivorous animals, and that is the way life is able to sustain today. Sun is responsible for this. And no doubt, because of this reason, sun has been revered as a god from ancient times. Any culture, Mesopotamian you take, Sumerian you take, ancient Egyptian you take, okay, or even our own Vedic civilization, or much earlier, Indus Valley civilization you take, sun has been revered because everybody knows that if there is darkness, nothing can be done. Sun is the one which, the giver of light. Okay, this is the ancient Egyptian god of the sun god Ra, R-A, Ra. Okay, and in our own culture, we have sun here, and it is called as Surya, Aditya, Divakara, Dinakara, Bhaskara, whatnot, Martanda, such things. And there are many hymns like Aditya Hrudaya. See, Aditya Hrudaya, it is related to the sun, chanting of shlokas. Early in the morning, people, once they see the sun, they become very emotional and chant this. Okay, so when India named its spacecraft, which was being built to study the sun exclusively, it was named as Aditya. It was very appropriate. Okay, so Ravi is the other name for Surya. Now, look at that. There have been many temples which have been dedicated to the sun in our own culture. Konark temple, one of the finest temples any one of you who has seen, it is dedicated, this is for the sun. Okay. Now, let me play a song very quickly for about half a minute. Look at that. Deepak, can you increase the volume?
Dinakara Subhakara, Dinakara Subhakara, Deva Dina, Dimira Samhara, Dinakara Subhakara.
Okay, he said, telling one who erases the darkness, Timira Samhara. Okay, so the kind of thing. Anyway, this is a very famous, let us say, song, devotional song from a movie of the yesteryears. But anyway, all of us know in our culture, Satrarjita, the name we know, Shamantakamani, we know, that is what he is getting from the sun. So this is part of Indian folklore, okay, Indian culture, Indian cultural ethos, okay. Everywhere, in all cultures you will find like this. Even those of you who have read Tintin novels, you will see that in one of them, okay. Anyway, sun is a star, I told you. Sun contains 99% of the mass of the solar system, 99, more than 99. And because of its enormous gravitational field, it keeps all other bodies of the solar system under its firm grip. Okay, that is the thing. And as I told you, Earth revolves around the sun in an orbit which averages at a distance of 15 crore kilometers from the sun. For comparison, take the case of Mercury, Buddha Graha. it is at 6 crore kilometers on the average. Excuse me. Venus, Shukra, 11 crore kilometers. Earth 15, Mars 23, Jupiter 78, like that. But we are at a distance of 15 crore kilometers. The sun is such an enormous thing, the thing is such an enormous body, okay? Sun doesn't have any solid surface. It is a glowing ball of plasma, hot gases, very hot gas. So if you consider the diameter of the sun, you can put from one side to the other 109 Earths. Such a big thing it is. So the implication is that, look at that, this is the sun, and compared to that this is the size of the Jupiter, Saturn, Uranus, Neptune, and blue colored thing, can you see, a marble kind of thing? This is the size of the Earth. It's very easy to imagine. You can put 13 lakh Earths inside one sun. So if you want to say in scientific terms, the volume of the sun is 13 lakh times the volume of the Earth. Now look at the sun. This is how the sun looks. At least you can look at the sun early in the morning or during twilight hours, okay, late in the evening. Don't look at the sun directly anyway. It is not good. Not that something will come and hit you, because it is so bright. It is not good to look at it. Nobody will look at the sun like that. But there was one person who looked at the sun not only using his naked eyes, but using a telescope. That was far, 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 far more dangerous, and he became blind during his old age. I'll tell you who he was. Anyway, all said and done, this is the way sun looks to us. Look, it looks like a circle kind of thing. Okay, it's a sphere, let us say. The light, the light giving part of the sun, from where we are able to see the sun because of this globe, this is called as photosphere, the sphere of light. Okay. But instead of looking at the sun through naked eyes, look at the sun through a very powerful telescope or a spacecraft image. This is the way the sun looks actually, it is full of granules kind of thing. Because I told you it's a seething ball of hot gases. Look at that. Here you will see how the sun is bubbling. The surface of the sun is bubbling as though, water is boiling. When water boils, this is the way you will see. Or even rice granules when rice is being prepared. This is the way it looks. So this is called granulation. This is the surface of, this is the photosphere. Then there are dark spots on the surface of the sun which are not visible to the naked eye easily, or let us say for all, because none of us will look at the sun continuously, but using a telescope, not directly, you can project the image of the sun, okay, on a paper or on a screen, and you can see. Even in our planetarium we can show, okay, in our planetarium we can show this, okay. So these are the sunspots. Sunspots are dark spots on the surface of the sun, photosphere. Look at the sunspots. Why they are dark? Really they are not dark, okay. If you look at the photosphere, what is the temperature? Do you know? If we are having a temperature of 35 degrees, 37 degrees, we say it is very hot, okay. In Sahara and such places, 50 degrees, like that it will be there, plus 50. We say it is intolerable. The surface temperature of the sun is 6,000 degrees centigrade. 6,000 degrees centigrade compared to this. But compared to the photosphere, which is 6,000 degrees centigrade, these sunspots which are on the photosphere, actually, they have a temperature which is 1,000 to 1,500 degrees lower. That is why against the background of a bright photosphere, they look dark. Otherwise, they are not dark. Their temperature also around 4,500 degrees centigrade. And I told you about a scientist or an individual who looked at the sun, not through his naked eyes, but through a telescope. He became blind during his old age. He is Galileo Galilei, the great scientist. And actually, thanks to him, the science progressed in that. Okay. He became blind in his old age, but the cause of science was served. That is what is important. But anyway, nowadays nobody sees the sun directly. Anyway, what is there? Nobody wants to see, because it is there always, people think. Only time during which people want to see the sun is during total solar eclipse. If you are of course, during total solar eclipse, you know that if the totality is about 25 seconds, for about 10 to 15 seconds, you can see. But make sure that you turn away afterwards. Otherwise, when the moon moves ahead, and suddenly if the light comes and hits your eye, it is very, very dangerous. That's why always better to see even the total solar eclipse using a filter always. That's it. Now, I told you about the surface of the sun, visible surface of the sun. Let me see. That is called as photosphere. That is what we see from the earth. Okay. And there is sun also has got an atmosphere like the earth, but the inner atmosphere of the sun is called chromosphere, sphere of colors, let us say. Chromosphere, you can see roughly here. This is the photosphere, chromosphere, and you can see chromosphere there during a total solar eclipse. Okay, you can see that red colored thing and yet another thing, and finally the outer atmosphere of the sun called corona. But one interesting thing is there. See, the thing is, when photosphere is 6,000 degrees centigrade temperature, chromosphere is still higher, 10,000 degrees centigrade. How is it possible? Forget about all these things. Corona is more than 1,000,000 degrees centigrade hot. Okay? The temperature is more than 1,000,000 degrees centigrade, 2 million, 3 million, it goes. How is it possible? The center of the sun is the hottest. As you move away from the center, temperature decreases. But in the solar atmosphere, especially for corona, it is away from the center of the sun compared to photosphere. But how is it possible? This is one of the enigmas, or this is one of the questions which has not been answered convincingly. There are different explanations. Okay. Now let us see. Whenever we see the sun, we don't see many of the violent activities which are taking place on the surface, on the sun's surface or in its atmosphere. Look at the sun. Sun has many violent activities all the time, but these violent activities become maximum during certain times. I'll come to that. Okay. Look at that. This is a huge explosion on the sun, photosphere, roughly. Let us say this is called a solar flare. Okay. It is similar to a volcanic explosion. A volcanic explosion throws out, okay, magma, and it becomes lava, as well as gases also thrown out. Here, particles are thrown out, as well as electromagnetic radiation. So this is a solar flare. You cannot see it from the surface of the earth using naked eyes. And this is a much impressive thing called a prominence. It is an arch which goes up and again goes back to the sun. I will show you an animation of a prominence. Look at that. See how violent it is. And you may say, oh, how big it is. After all, nothing, isn't it? Okay. Look at this explosion, a prominence. It's an arch which again goes back to the sun. Yeah. Look at that, loops back to the sun. Look at the earth. This is Jupiter. This is earth. Compared to that, how big a solar prominence is. See, everything is giant in this universe. So these are the violent activities. So what? Let us know about them and clap our hands and let's go away. That's not like that. There is an implication of all these things. Now, we learnt about the surface of the sun as well as its inner atmosphere, chromosphere, and the outer atmosphere, corona or the crown. What about the structure of the sun towards its center, internal structure of the sun? The central portion of the sun is called core, and next to that is a thing called radiative zone. Next to that is a convection zone, and finally you have photosphere, like that. Okay, core, radiative zone, convection zone, photosphere. Then chromosphere and corona is the atmosphere of the sun. It is very interesting to know that sun is generating enormous amount of energy due to thermonuclear reactions which are taking place inside the core of the sun. Okay. So look at that. Actually, let's not worry too much. Okay. You know, all of you have heard the name hydrogen. Okay. Hydrogen is a gas, all of us know, but it is an element. In the center of the sun, in the core of the sun, 4 hydrogen atoms are combining in a special way. We call it as fusing. That is why fusion. They are combining to form the next element, helium. In that process, a very little mass is disappearing. Disappearing out of this universe? No. Einstein said mass and energy, they are the same. The famous equation E equals mc squared is there. According to that equation only, when 4 hydrogen atoms are fusing and building a helium nucleus, some amount of energy, you take the mass of the helium nucleus, you take the mass of the 4 hydrogen atoms, there is a difference. That difference is getting converted to energy. Can you believe every second, by the time you blink once, 600 million tons of matter is undergoing fusion. 600 million tons of hydrogen, it is getting fused into helium. In that process, anywhere roughly people say 3 million, 4 million, like that. Let us say 3 million tons of mass every second is getting converted to energy. That is the reason why sun radiates enormous energy. Yet another interesting thing is there. Sun actually, when it is generating energy at its core, what it is generating is not heat and light. No. It is generating gamma rays, which is the most energetic thing. But by the time that gamma ray goes out, okay, travels outwards from the core it has to travel towards radiative zone, then convection zone, okay, convective zone, then finally photosphere, and then it has to escape through the solar atmosphere. To travel from the core to the surface of the sun, it may take a few 100,000 years or a million years even. Can you believe all these things? But by the time it goes to photosphere and gets radiated, within 8.33 minutes, it comes to Earth. See the bizarre thing. This is what is happening. Okay, now anyway, I told you about convective zone, this, that, and such things. In this slide, I want to show you what is a solar wind. Sun emits a continuous stream of particles, continuous, every second it is going, not too much, okay, at a particular rate it is radiating, let us say, or it is throwing out or emitting, okay. These particles together, they are known as solar wind, okay, solar wind. Look at that. Throughout the solar system, you can see the solar wind. Sun is there in the center, inner planets, outer planets, and all those things. And two, two spacecraft have gone beyond the solar system in one sense, because they have crossed a boundary where solar wind is not at all prominent, but interplanetary particles from the interplanetary space, they are dominant. Now, when sun emits solar wind, okay, these solar wind particles, they come and they cannot come and hit the earth just like that. Otherwise, again, it would have been danger for us. But earth has got a protective magnetic field. It doesn't allow solar wind particles to come and go everywhere. Normally, they are channeled towards the polar areas, okay. Those in the polar areas where they are channeled, you can see this beautiful light display. They are known as auroras or aurorae, plural. In the northern hemisphere, it is known as aurora borealis. In the southern hemisphere, it is called as aurora australis. Sometime back, almost, let us say, some 27 years back, okay, nearly 30 years back, I was in Alaska. I have been a witness to the aurora borealis. One of the most enjoyable things, one of the most frightening things, because we are not used to that kind of color display in the sky. It is fantastic. Okay, now let us come back to the emissions from the sun. Eruptive emissions, which are dangerous. which are highly energetic. See, I'm telling you, this is a solar flare. How it is coming out, you see. And this is the prominence again. I'm showing you just to make you, okay. Now, these, solar wind is coming like this, but if there is an eruption like this, okay, a solar flare, sometimes a solar flare is associated with a giant cloud of plasma, okay, a giant cloud of particles. Let me more general. It is known as coronal mass ejection, CMEs. If they come and hit the magnetic field of the earth, they will just compress our earth's magnetic field, and the auroras which are visible in the polar regions come down towards the lower latitudes also. This time it has happened. At the same time, these solar flares, that is the electromagnetic radiation, as well as the particles, they come and create havoc in the earth's magnetic field, and it is called as a geomagnetic storm. What do they do? Let us see. Why observing the sun is very important today? 24 hours a day. Why do we want to observe the sun? The reason is this: we are slavish to technology. We are slaves to technology. From 19th century onwards, we are using electricity heavily. Think of being without electric power. You can even think of without being without mobiles. But without electricity, it is very difficult. Artificial satellites, computers, all these are electronic gadgets. This solar storms are, the thing is, the solar flares and coronal mass ejections, ultimately, they create geomagnetic storm, and some of the effects of that are, these satellites can be actually, even in rare cases, they go bust. In the sense, they are destroyed also. That is, they become inoperable. It is not sometime very rarely which has happened. Elon Musk's, Starlink series of satellites, very well, already nearly 4,000 satellites he has launched. Some of them, one whole lot of satellites which were launched by a rocket, his own rocket, Falcon 9. They become inoperable due to a solar storm, just about 1.5 years back or something like that. So it's very dangerous, and at the same time, GPS signals, many of us navigate today. Where is Jawaharlal Nehru Planetarium? Google Earth, Google, let me say. Let me see this one, we say. Okay? That is the kind of thing. Scintillation of GPS signals. Scintillation means, okay, anyway, some kind of static kind of thing. Scintillation means just like that, some kind of disturbance in that happens. High frequency radio communication gets affected, and aeroplanes also cannot navigate properly. And more than anything else, these coronal mass ejections and solar flares, they can create havoc in the electrical power grids. In 1989 in Canada, for about 9 to 10 hours, there was no electricity. The electric grid in Quebec province got knocked out due to a solar storm. So this is the reason why, at least can we get, say, a forewarning of these kind of happenings. In fact, if we can get, it would be good. That is the reason why we want to study the sun. We want to observe the sun 24 hours a day. This is the reason. See, sun, for a long time it has been observed, not 300, 400 years or anything like that. Sun gets angry every 11 years. In fact, it is very angry now. It will be angriest, let us say, just for fun sake I am telling, next year, 2025. We call it as solar maximum. In 2025, so in 2020 it was not that angry. In 2014 it was angry. So again, 2025 it is going to be very angry, this kind of thing. So when sun is very angry, this kind of solar flares, coronal mass ejections, all these things will increase. Already this year, Americans, they have a center called Space Weather Center. At North American Aerospace Defense Command, actually, they will be monitoring with the help of satellites and other sensors. They say one solar flare has been seen on the sun. There are different class of solar flares. Okay, so this may cause havoc. So, and their prediction has been authenticated, because in the Pacific area and even in the Atlantic area, in the West Indies and such places, radio communication got totally blocked out for some time. So you don't want such things to happen. You don't want your lifestyle to be adversely affected by the angry sun. So if you get a forewarning of that, it would be good. This is HF communication radio I am showing, and a lot of satellites are circling the earth. I told you their electronics can go haywire if the particles from the solar wind and the coronal mass ejection, they come and hit the satellites. In fact, earlier one satellite got affected adversely due to this. And what about International Space Station? Including Sunita Williams, there are 9 people who are circling the Earth today in the International Space Station. Apart from that, you have 3 taikonauts in the Chinese Tiangong Space Station. 12 people are there. They are exposed to the sun directly. There is no protection from the atmosphere for them, because they are outside the Earth's atmosphere. They are circling the Earth. And especially if the astronauts are outside their spacecraft and making a spacewalk. Look at that. This is a spacewalk 50 years back by American Edward White. So if they are exposed to space like this, and if there is a solar storm, and if there is a coronal mass ejection, the after effects of which, if they affect, their health gets severely affected. So that is why it is very important to monitor. And I told you, electrical power grids, you cannot afford to have such things. And let us see how humans are studying the sun. For a long time, at least till from the time of the invention of the telescope in 1609 AD, and it's used by Galileo Galilei. Okay, so sun was studied using telescopes, not directly looking at least projecting the image. But I told you, from the surface of the earth, you can study the sun through visible light as well as radio waves. But once artificial earth satellites came to be launched, okay, came into use, when they're outside the earth's atmosphere, there is no question of atmosphere filtering all other electromagnetic radiations out. So you can study the sun in gamma rays, in X-rays, in ultraviolet, in the visible, in the infrared, using radio waves, what not infrared, you can study. So using satellites, and look at that, this was a space station called Skylab. Many people may know it, it became notorious because in 1979, it had an uncontrolled re-entry into the atmosphere. It was 80-ton spacecraft. Many people thought that it would fall on their head. Okay, I still remember my physics professor was teaching LCR circuit on that day. His name was Professor Sridhar Murthy Rao. One of my friends got up in 1979 and said, "Sir, I am scared. Please let the class off. Okay, I want to go and stay inside my house because I am scared of Skylab." The class was let out, of course. That is the reality. But fortunately, it didn't fall anywhere in the populated areas. They controlled it somehow. Okay, they didn't have any rocket engine, but somehow by controlling its orientation, they could able to do something. Only in Western Australia and the Pacific it fell. And by the time, much of it was disintegrated. But this is not the case. Now there are techniques which can be used. Okay, why I showed Skylab? It had a solar telescope. I showed you a picture of the prominence that was taken by Skylab. And of course, this is a spacecraft called Ulysses. Ulysses, okay? This is the one which studied the polar areas of the sun. Like Earth has a North Pole and South Pole, you have poles for the sun also. And now we have yet another satellite called SOHO, Solar and Heliospheric Observatory, which is at a place which is 1.5 million kilometers or 15 lakh kilometers away from the earth, from where you can see the sun, study the sun 24 hours a day, And the latest addition to that is our Aditya L1. I will tell you what it is. Apart from this, we have a wonderful spacecraft which is studying the sun called Parker Solar Probe. The wonderful thing about this is it has already touched the sun. How is it possible? Touch the sun means it has gone to the outer atmosphere of the sun already, corona. Now, this December, believe me, this December, it is going to a distance of only 60 lakh kilometers from the surface of the sun. 60 lakh kilometers, 6 million kilometers. 60 lakh kilometers from the surface of the sun. Already it has gone at 80 lakh or something like that. Now, this December, 2024 December, only it will be passing near the sun at a distance of 60 lakh kilometers, which is nothing but corona. Okay? And we have yet another spacecraft called Solar Orbiter by the European Space Agency. Parker Solar Probe will go very near to the sun, but it cannot take the picture of the sun from there. Cameras will melt, that's all. Fortunately, the spacecraft is not melting due to a heat shield. You can see that. This is the heat shield, what you see. But Solar Orbiter also has got a heat shield, but it is 10 times the distance of Parker Solar Probe. It is quite far away, so it is capable of taking the picture of the sun. This is European Space Agency's thing. And now, I told you, we are very near to the angriest phase of the sun now. This is called solar cycle 25, 25th cycle which has been recorded. Okay, solar, this one, phase 25, it is there. Okay, solar cycle 25, and you can see a coronal mass ejection, how it is being ejected. In fact, lot of particles, how they are being ejected. This was taken by a spacecraft which was circling the Earth. But anyway, beautifully it has it. It is circling the Earth, means it cannot see the sun 24 hours a day. But when it could able to observe the sun, it took this picture. So 2025 is the time when the solar activity will be peaked, will be at its peak in this cycle, in these 11 years. Okay? So be ready to face the angry sun. All of us have to be. Now, see, Aditya L1 is the latest addition to the series of spacecraft which are studying the sun. So, what is this Aditya L1? What is so special about it? Now, let me tell you, before going to Aditya L1, let me tell you, India has a history of sending different scientific spacecraft into space. The very first Indian satellite, Aryabhata, was a scientific satellite, and it had an instrument to study the sun. Do you know this? As early as 1975. Okay, this was there. And now, anyway, Aditya L1, Aryabhata was circling the Earth at a distance of 600 kilometers. But Aditya L1 is going to a place which is 1.5 million kilometers away from the Earth. Okay, 1.5, 15 lakh kilometers from the Earth towards the sun in a straight line. Okay, it is called L1 Lagrangian point. I'll tell you why. Okay, this region which is 1.5 million kilometers, that is 15 lakh kilometers from the Earth towards the sun. Okay, look at that, a straight line from the Earth towards the sun at a distance of 15 lakh kilometers. Here is the sun. If this distance is 15 lakh, this distance is 15 crores. Okay, 1/100th of the distance between the Earth and the sun, that is the distance at which L1 Lagrangian point is there, and that is where Aditya L1 is situated now. That is why the tile L1 is there. Aditya L1 means it is at L1 Lagrangian point. What is so special about Lagrangian point? Look at that. At Lagrangian points, there are 5 Lagrangian points. Let's not worry too much. The first one, L1, whatever is there. Can you see that? See, it is on the line between on the line joining the Earth and the sun. Look at that. It is circling the sun at the same rate at which Earth is circling the sun. So it is in a straight line always. Actually, at its distance, it should be circling the sun at a greater speed, but it is not taking, it is not doing that. Why? The gravitational fields of the Earth and the sun at that place, they balance out each other. That is an advantage. You can study the sun from there 24 hours a day. At the same time, you can point your communication antenna towards the Earth 24 hours a day. You can get real-time information then and there itself. So that is about L1 Lagrangian point. And let us enjoy the launch of Aditya L1 on September 2nd, 2023. That's why at least on September 22nd, we are having a lecture here on Aditya L1. We have an exhibition outside of Aditya L1 panels. Kindly have a look at it. And this is the PSLV.
3, 2, 1, 0.
Look at that, the majestic flight of PSLV
Plus 5
lifted off.
Lift off,
And
normal P1 tracking.
PC tracking.
Magnificent liftoff of PSLV C-57 with Aditya
it
L1 on
took
board.
more than an hour for the rocket to inject the spacecraft into an orbit around the Earth first, not sun directly. Look at that, how majestically the rocket is flying. Yeah. Each event which has to take place after its launch has taken place exactly as planned, and Aditya L1 took 126 days to reach L1 Lagrange point after its launch. 126 days means more than 4 months. My dear friends, it is not easy to inject a spacecraft there, and it is India's first attempt, and it has done it perfectly. Be proud of India. That is the thing. Look at that. This is the way. See, first it was, let us say, the orbit was like this. Let us say it was not exactly like this. See, perigee and apogee, nearest point to Earth and the farthest point to Earth. Yeah. Every time the orbit of Aditya L1 was raised using its own rocket engine, and finally at one point it was made to escape from the gravitational field of the Earth. See, gravitational field of the Earth is prominent up to that point. That red line is going, there is one dotted line there, in fact, discontinuous line. Yeah, okay. So, that is earthbound phase. It has crossed. It is in the interplanetary space. Sorry. And see the way in which, see, that is 1.5 million kilometers, L1 Lagrangian point. So, it is going there. It went there like that. It was deliberately made to go there and got injected into a so-called halo orbit around Lagrangian. At Lagrangian point itself, if you keep this spacecraft, it will not be totally stable. Just a push will disturb it. And such forces are plenty in space. So if you put it into an orbit, which is very complicated, I am showing like this, okay, around L1, it is quite safe. And we have maintained it. We means Indians. I am not speaking on behalf of ISRO. Anyway, Indians have done it. We have to be proud of this. So this is the way the spacecraft is there. This is the way Aditya looked when its panels were folded. What are the, in the next 5 minutes I am going to finish off. What are the objectives of Aditya L1? What does it want to do? What do you want it to do? One thing is coronal heating, we want to study. I told you, corona, that is the outer atmosphere of the sun, is quite far away from the center of the sun, but it is having the highest temperature compared to photosphere. Photosphere 6,000, chromosphere 10,000, corona more than 1 million degrees. Why it is like that? Coronal heating is one of the reasons why it is like that. What is the mechanism responsible for that? That is being studied. And solar wind acceleration, I told you, a stream of particles that are continuously emitted by the sun, it is called solar wind. And certain times during a coronal mass ejection or a solar flare, let us say, solar wind gets accelerated. So normally they come at a slow pace. Suddenly if they come and hit some satellite means, why? What mechanism is responsible for solar wind acceleration? That is the second point. Third point is coronal mass ejections. I told you. Big cloud of gigantic cloud of particles coming and hitting the earth or in any other direction. So why? What is responsible for the initiation of coronal mass ejections? That is the thing. And its impact on the near Earth space weather, near the Earth, let us say at L1 Lagrangian point or around that, what happens because of that coronal mass ejections? We want to study. That's why I said Aditya is having 3 instruments which can taste, I said. Particles, ions, magnetic fields. It has got, I'll show you. And of course, how solar wind is distributed in space. Why there is chromosphere, so that you can see corona, only corona. Then solar ultraviolet, this is built by Indian Institute of Astrophysics in Bangalore. And here solar ultraviolet imaging telescope is there. This is from Inter-University Center for Astronomy and Astrophysics, that is in Pune, IUCA, we say. That is the thing. And we have got one low energy X-ray spectrometer, one high energy X-ray spectrometer. That's why I said 4 eyes. One is coronagraph, the other one is solar ultraviolet imaging telescope, third and fourth X-ray telescopes. Okay, these are the 2. Okay, and of course 3 instruments taste. I said one taster is this magnetometer, the other one is PAPA, plasma analysis package for Aditya, and these 2 Swiss and steps, they make up what is known as aspects, that is Aditya solar wind particle experiment. Particles, ions, magnetic fields. So tasting things 3. So with these things, Aditya is able to take a holistic look at the sun. Look at that. This is a picture from suit. Okay, solar ultraviolet imaging telescope at different wavelengths. They have used filters to split the light, and each wavelength provides you a particular information. Look at that. And of course, there are a lot of X-ray flares. They have taken pictures of that. Okay, this is not from Aditya, let me tell you. I'm just showing you actually how an X-ray flare is there. And of course, this is the way now Aditya is there between the earth and the sun, but don't get confused by the scale shown here. This distance is only 15 lakh, but this distance is 15 crores, 100 times that. And see, by studying these things, if you are able to generate an early warning of this, disturbances in space weather, geomagnetic storm, you will be saving your own satellites, your own power grids, your own high frequency communications you will be able to manage, GPS signals you will be able to manage. Okay, there are techniques for doing that. So you will be able to do it. And Aditya is supposed to work for 5 years. Already 1 year is over. So it is continuously observing the sun. And Aditya is India's contribution to the study of the sun, a holistic study of the sun, to understand many things about the sun, using which we can generate 4 warnings of dangerous things which may happen to Earth, in fact. So sun is a very interesting body, and humans have studied the sun from time immemorial. Studied means at least they have revered it from time immemorial. For the past 400 years, they are scientifically studying the sun, okay, using modern scientific methods. And now in the past 60, 70 years, they are using spacecraft to study the sun. And the latest addition to the series of solar observation spacecraft is your own Aditya L1. Thank you. Thank you very much. And in the past 50 minutes or 55 minutes, I've tried my level best to honestly give you a popular view of what is Aditya L1, where it is, why it's being launched, why it was launched, and what it is doing, okay, why it should do the way it is doing, and what are the benefits. So thank you very much. Especially I would like to thank Mr. Ravi and Sharanya and Mr. Deepak. Deepak has helped me in many of the visuals. Thank you, Deepak, once again. And Sharanya, of course, in popularizing. So thank you very much to all of them. It is not only my effort. Many people have helped me. I must acknowledge that. Okay, so Thanks a lot, Mr. Patil, Srinivas, all of them are there. So I thank one and all the staff of our planetarium, okay, in making this lecture, bringing this to this stage. I would say. Thank you very much. If you have any questions which I can answer, yes.
Why can't we make the energy that is being released during the mixing of hydrogen and hydrogen atom to create a helium atom on Earth itself?
That is because, very good question, I say, philosophical question. Okay, sit. I told everybody that 4 hydrogen atoms are getting fused into helium and energy, a part of it, mass is getting disappearing and getting converted to energy. Why the same process cannot be repeated here on Earth? He is asking why we can make use of that process to generate energy here. Very good question, very good suggestion, but the kind of pressures, the kind of temperature which is there in the core of the sun, we cannot create like that. For example, controlled nuclear fusion reactors are being designed, but it is not easy, because how do you contain that hydrogen nuclei? You cannot use a steel vessel easily. If they come in contact with any vessel's walls, contamination will be. It's not easy. So they use magnetic means, they use lasers to heat, but still such reactions have worked. But such, even at the experimental stage, such reactors are not able to mimic it and generate energy in excess of whatever was supplied. So that is the reason. Good question. It's a very fantastic thing. Yes, you have another thing? No. Very good. I'm sorry.
Sir, what was the speed at which it was traveling, the velocity?
See, if it is light, it is 3 lakh kilometers per second.
No, I'm sorry, I'm talking about the spacecraft.
Which spacecraft?
Sir.
Oh, the one which is very near to the sun.
Parker.
That Parker solar probe is about 400,000 kilometers or something. 3 to 4 lakh kilometers. Believe me.
So it's traveling at 4 lakh kilometers per hour.
Yes. Okay. No, not 400 kilometers per hour, second.
400, no, you said 4 lakh.
No. 400 kilometers per hour. Sorry, per second.
Per second,
See,
400.
if a satellite is circling the earth at 200 kilometers height, it is 8 kilometers per second. But this, again and again, it has taken gravitational boost from different planets, and when it is very near to the sun, okay, there was a great person by name Kepler. He said something, when it is very near to the sun, a planet is, when it is very near to the sun, it is moving fastest. So again, what is the speed with which it is moving means where it is, it matters. When it is very near to the sun, at 60 lakh kilometers, I said, maybe 300,000 kilometers, 300 kilometers per second. 300 to 400 kilometers per second.
Yeah.
That's what I mean.
Sir, like the other agencies which have launched this, are they not sharing the data for
They
which?
are sharing. See, all the things, scientific data, everything is being, by and large, is being shared. But the first preference will be to the people who have designed those instruments. Even in India, that is. After some time, I am sure, I don't know how much it is being shared now, but India, there is a place very near to Bangalore called Byalalu. There is a thing called Indian Space Science Data Center. There, whatever data has come from Aditya is resident there in that repository. You can register it, you can use it. Nobody prevents.
No, in general, other agencies also
Yes,
share.
they share. Scientific means they share.
No, like 100%. No, otherwise, was there any necessity for ISRO to particularly launch? Like most of the times we find in defense,
That
others
is
doesn't.
different, but anyway, it's a good question. Why, if data is available like that, why did we launch Aditya?
Yeah, I would say
Because Aditya has got certain advantage.
that. No doubt, we are proud
I
of
will
it.
tell you, they are there. For example, the way in which, the solar disk is there and coronal mass ejections are from corona. how nearer to the surface of the sun you can study. Aditya is having one of the best instruments, solar ultraviolet imaging telescope. Okay.
And again, all are completely indigenous, sir.
Yes.
Again, I have heard
they are
satellite
designed-
technology is not shared by anybody.
No. Scientific things, it is not a problem. Only certain things, pictures, this, that, and GPS sometimes. Nowadays, I don't think so. But anyway, we have our own navigation satellite system. We have our own, let us say, remote sensing satellite system, communication satellite system, weather satellite system. We need not have to worry.
Last question, sir. Like
Please,
we
please.
find that in our country, ISRO is one of the agency which is doing wonderful work without depending on anybody else. Why similar things are not happening in other areas like say software or aerospace? You know.
I don't know. Software, it is happening, no doubt about it.
No, recently there was an article in newspaper where they were telling that we don't have our own operating system.
Sir, I'm not from those areas. Anyway,
just
as a science writer and broadcaster, you see, I'm not speaking on behalf of ISRO. Even today in lecture, I don't want to say that I'm speaking on behalf of JNP kind of thing. Okay? As a passionate science writer and broadcaster, I'm speaking. But let me say, to my knowledge, ISRO is sharing scientific data with the world at large. Chandrayaan, Astrosat, Megatropics, okay? All these things, they are being shared. Mangalyaan even, they are being shared. Like that Aditya also being shared, I think. I have not seen. Definitely it will be shared. As far as sharing of scientific data is concerned, I don't think there is any problem. Scientists all over the world, they want to collaborate. So that is the thing. But why it is not in other areas, I don't know why they are.
Sir, it was a wonderful lecture. Thank you.
I am very proud of our achievements in space. Achievements in space means we have done this, I am not interested in that only. What is the basis of that? Whatever these kids learn in their school, in physics, chemistry, mathematics, that is the basis for whatever we do in space. May not be at that level, you have to go to a higher level. That I recognize. Come what may others think. I am firmly a believer in this. Okay? That's it.
Sir, it was really wonderful. Thank you so much.
Very kind of you, sir. My pleasure.
Not only the operating system, it is the entire the software chain, right? So operating system is only for the computer. Then you have a lot of programs which we use, right? So it is a big ecosystem, right? So it is not only the operating system. And I think we have a mobile operating system to start with. I forgot the name. Our Indian, one of the company or organization, they made it for mobile. Probably they can make it for the computer also. Mhm. Yeah. Correct. Yeah. So it is not only the operating system, it is a big ecosystem, right? Lot of application and the programs, right? So that ecosystem is already there. So if you want to build your own ecosystem like that, it will take a lot of resources. And if something is already there, which is easily available, like Linux is there, it is available for free, right? So people tend to take that and develop around it. There is no point in investing. Definitely for the defense and space applications, they will have their own things.
Any other question? Yeah.
Sir, sun has mostly hydrogen and helium, right, sir? So when coronal mass ejections, so kind of like hydrogen comes out, or is there some other, what is getting ejected? You told particles are getting
Yes,
ejected.
particle, protons, electrons,
Oh, like
and
that. Oh,
to a certain extent, to a very small extent, other nuclei have. But the thing is protons and electrons, mainly. Solar wind particles, that is the thing. Whatever comes in solar wind, by and large, coronal mass ejections means one is ions as well as this one, particles. Particles means neutral particles, and ion means it has got an electrical charge, that kind. But nothing will happen to the sun, don't worry. Because as I told you, every second 600 million tons of matter is getting fused. Don't get confused. 600 tons is participating in the nuclear fusion, hydrogen. out of which 3 to 4 million tons is getting converted to energy every second according to E equals mc squared. Yes, you have some.
So L1 point is a point where the gravitational force is equal, right, between Earth and
Cancel
Sun.
out,
Cancel
roughly,
out, yeah.
roughly, yes.
But it's not just a two-body system, right? There are like other planets. Like,
Yeah,
are their influence
yeah,
less,
yeah,
or
yeah.
we don't have to include them, or
For the time being, no. Because, the thing is, when look at the distance,
okay,
look at the gravitational field of the sun. It is enormous. And look at the gravitational field of the earth. It is having a limited scope. But the thing is, spacecraft is relatively near. The question of Mars influencing it, the question of Venus influencing it will not come at the popular level, in the sense the gravitational field of the earth due to the nearness, the enormous gravitational field of the earth due to its mass, they are the major contributing factors for it. They overwhelm everything else. Two-body problem, but the third body is the spacecraft. Okay? Good. Anything else? No. Okay. Anything from... okay. If there are no questions, thanks a lot then. And once again, I thank all my colleagues who have helped me in this regard. And thank you very much for coming and participating in this lecture. Shortly, we will have one more. The thing is, let me announce this. Let me tell you one thing. Please treat whatever I have told you in the past 1 hour as though it is coming from a passionate science communicator and not as an ISRO scientist earlier, as an ISRO spokesman. No, I'm not a spokesman for anybody. I'm a passionate science communicator. That's what I have done. Please treat it as though it is coming from a science communicator, Guruprasad, not anything else. Okay, thanks a lot. And in 2 days, September 24th, 2024 happens to be the 10th anniversary of the successful putting into orbit of India's Mangalyaan spacecraft. To commemorate that and what it did, why Mars is important, there will be an exhibition outside after Tuesday. And shortly we will have one more lecture on that. I'll be delivering on the significance of Mars orbiter mission. That would be wonderful, really. In a book recently brought out by Hindu, I have shared it. But anyway, as to how romantic the mission was, Mangalyaan, I can share it with you during my experience in ISRO at that time. What India did and how India got elevated like anything in the domain of space, each and everyone saluted in fact. That is it was a red letter day in the history of India of 5,000 years, because India became the first Asian country to reach Mars, not even China, Japan, nobody. And ISRO became the first space agency to score 100% success. I repeat, 100% success in its very first attempt to explore Mars. NASA has explored Mars wonderfully, no doubt about it. But NASA also did not score 100% success in its very first attempt, which your India did. So kindly, we will announce it. So kindly do it. Budget, as the Prime Minister, Honorable Prime Minister Narendra Modi ji said, less than the budget of gravity kind of thing. And that's the way it is. But anyway, many people say that India said we are better than America. No, don't say like that. What India proved was, you should not compare like that. What India proved was, yes, we can do a planetary mission at a low cost. That's what it did. Let's not compare and all. Okay? Please, we'll send you the information. Kindly do tell your friends. Really, I have got some of the best visuals pertaining to Mars orbiter mission. So I would like to share with you. Thank you. Thank you very much.